The RRC4 is a two-board stack that conforms to the Adafruit feather and wing format. The Photon 2 feather board on top is the brains, a highly capable 32-bit M4 Cortex processor with Bluetooth, Wi-Fi, and a rich collection of peripherals. The RRC4 wing board on the bottom has all your flight sensors and I/O, where you'll make all your wiring connections. Let's start with the terminal block, the most important connectors on the board. You have 4 Pyro output channels: Drogue, Main, aux1, and aux2. Every channel is 4 amp capable, peaking up to 8 amps for high-demand applications. Drogue fires at apogee. Main fires at your set altitude on descent. aux1 and aux2 are fully programmable, staging, air start, whatever your flight profile demands. Power comes from a 1S LiPo or lithium-ion battery via the BAT+ and BAT- connections on the terminal block. The RRC4 is polarity protected. However, you should avoid surprises. The RRC4 needs a minimum of 3.7 volts nominal. Validate your cell charge and voltage before every flight. The power switch connector sits in series with your positive battery wire. This is your arm-disarm loop. Open the loop, the board is off. Close it, power flows. In an avionics bay, this is typically an internal switch. Keep all your power wiring short and your connections secure. The USB Micro B port handles 2 things: supply charging power your battery and running the command line interface. To charge your lithium battery, use the JST-PH connector on the Photon 2 feather board. Ensure your battery polarity is correct. For the CLI, open a serial terminal and press the H key for a full command list. This is where you pull raw flight data or do specialized operations like simulated flights and testing. 2 more inputs on the board: the brake wire connector and the 5-volt analog sensing input. The brake wire is used to detect external connection status. Wire it across a separation point switch, and the RRC4 knows the moment it transitions. The analog input will be capable of pressure transducer recording in future firmware versions. The GPS T4 telemetry downlink connector gives you real-time tracking data during ascent and descent. Connecting your T4 provides real-time downlinked GPS coordinates and live RRC4 data throughout your flight. The tricolor LED cluster tells you exactly what state the RRC4 is in during operation. At power on, you get a yellow slow blink. That's your 20-second window to connect in MDAX before the board arms. Green blink means system init. Green solid is the power-on self-test, or post mode, that performs all the pre-launch diagnostics. Blue breathing is launch detect. It's armed and waiting for launch. Once you're flying, blue solid. Cyan on descent. White breathing after landing. That's your completion state. The blue color status LED on the Photon 2 feather shows Bluetooth connection state. Now you know every connector and terminal on this board. Episode 3 is where we put it to work, programming your deployment altitudes, configuring aux channels, and setting up MDAX for the first time. See you on the pad!